Hi guys, let's start this week's tutorial sheet 3, week 3, so tutorial sheet 3. We are going to work on today. So let's get started. Let me share my screen. Okay, so let's start with the first exercise. If someone wants to answer, please unmute himself or herself and tell me, because I cannot see the chat. Okay, I can't read the chat. So the first exercise is, what is the cardinality of the following sets? So first of all, what does cardinality mean? What is cardinality? What does it mean? What is cardinality? Cardinality means the number of elements of a set. Number of elements in a set. Right? So let's see, the first is this. What is this set? What do we call this set?
Empty set.
Empty set, yes. What is the cardinality of the empty set?
0.
0, yes. Very good, Ashok, since it's empty. Very good. Number of elements is 0. Next one. A, B, C. What is the cardinality of this set?
3.
Yes, because one element is A, one element is this set, and one element is this set. Very good. So it is 3. Great. Then someone should mute the microphone, please. Someone should mute the microphone. What is the number of elements of this set?
0.
Not 0.
2.
Why is it 2?
Empty set.
It's a count, right? Because it's a count.
This as an element and has this set as an element. So we have these 2 elements. Okay, that's why it is 2. And then
One.
Yes, it's just 1, because this is the only element in this set. The element of this set is this set. And then we have someone should mute the microphone, please. Okay. Yes, we have A as an element, this set containing A as an element, and this set is an element. So it's 3. Yes. Okay. Let's go further. We are going to do exercise 11. Exercise 11. I want to go through definitely on every kind of exercise you will have in the exam. So I will give you every information in the test. You won't have any exercise which we don't do here in the tutorials. So every exercise will be covered during the tutorials. Okay, just you need to attend. So exercise 11. F of x equals x minus 2 times x minus 4. So this is our function. This is how our function is defined. What is this I have written here? What is this?
Limits of a function.
Yeah, this is a domain.
Domain, yes, very good. So the proper expression is the domain of f. Domain of the function is f. What does the domain of a function mean? What does it mean?
A set of permissible input values.
Yes, yeah, very input values, typical computer science person, yes. So the x is where the function is defined. These are the only values, okay, for which we calculate the function values. We don't care anything else. We don't care here in this case. Since whoever defined this function, probably Yi defined this function, she said that this is the domain. That means we don't need to care about x's which are smaller than 3 or greater than 10. Okay? So this is the domain of the function. Let's find f of 6. What is f of 6? What we need to do is to substitute 6 in place of x's. So this is 4 times 2.
8.
24, right? Then what is, the question B we have answered. What is the domain? We said that this is the domain. Okay. Often what is the domain of a function? Many times what is given as a domain? Many times the entire real set is the domain, often, right? It is a possible domain, but not in our case. In our case, the domain is only these real numbers, every real number between 4 and 10. Okay, then what is f of 6? F of 6 is f of, we have already calculated.
No. F of 24.
Sorry, here I made a mistake. Okay.
It's called 8, ma'am.
Yeah, it's 8, ma'am.
So thank you very much. Thanks. Sorry, we did this. Yeah, you're right. Yes, thank you very much. It's 4 times 2. Yes, it's 8. Yes.
And it will f of 8.
Yes, it is f of 8. So we need to put 8 in place of x. So we have
24.
6 times 4. So this is 24.
24.
Yes, this is 25. Right? 6 times 4. Yes. So f of 8 is 24. Okay, and then graph f of x. It says graph f of x, which means we need to graph it in the coordinate system. So x, where can we find x? Where can we choose x from? Only from the domain. Only from the domain. That is, 4 is the smallest number which is in the domain, and 10 is the greatest. So we are only interested in this part of the real line. So what is f of 4? If we substitute 4 in place of x, this is 0 times anything is 0. So it will be 0. F of 4 is 0. Then what is, let's say, we have the value for f of 6. So if this is 6, it is 8. So it's somewhere here. Then we have f of 8. So let's say 8 is here. It is 24. So it's somewhere up here. And f of 10. What is f of 10? It is 10 minus 2 times 10 minus 4. So it's 8 times 6, 48.
48.
Yes, so if I substitute 10 in place of x, I get 48. So let me try to make a curve. So for example, approximately, okay, so this is, it belongs to 10. So this value is 48. Okay, because this belongs to 10. It's 48. This is 4, so this belongs to 0. And it takes every value in between. So again, what is the domain of the function? This is the domain, the axis between 4 and 10. So the domain is on the x-axis. It's either called, usually called x, or often it is called t as time, or can be theta, so many things. Most of often it is x or t for time. And the range is the y values the function takes. This is the range. Range is the y, this is the y-axis, y values, or with other words, f of x is the same as the y values. Y values the function takes, this is the range. Okay, now the question is whether the function in the given domain is monotonic increasing or decreasing.
Monotonic increasing.
Increasing, yes, it says it's monotonic increasing. How do we know it's increasing? It's easy to tell because for greater x values, greater y values belong to. So we can see it's increasing. What does monotonic increasing mean? What does the monotonic mean? And one more question. Is it strictly monotonic increasing? Is it strictly monotonic increasing? What does it mean?
Just because it is going on positive way, that's why we call monotonic increasing.
Okay, so let's...
Yeah.
Yes, okay. So let's examine what increasing means. Monotonic strictly. Let me draw you a function. Is it increasing? Is this function increasing?
Yes.
Yes. So why? What makes you think it is increasing? Because you can see an overall tendency of increase, right? So if you see this, we can see that, okay, increasing. Is it monotonic increasing? Is this function monotonic increasing?
No.
Yes,
Why not? Why not?
Yes.
Now, yes or no? So
Yes.
we can see it's increasing. Someone says it's increasing but not monotonic increasing. Why?
Because at some values it is equal to, so it's not monotonic increase.
Because
yes, no, just because it's not monotonic increasing.
it's not monotonic increasing. Why not? Because there are some values when it reaches a point of the y-axis and then it drops back a little bit. Okay? Okay, it again reaches this value, but then it drops back again. It reaches the way, but it drops back. So there is an overall increase, but there are points where after reaching a y value, okay, then the function drops back a bit. So it's not monotonic increasing. If it's monotonic increasing, it means that once it has reached a particular y value, it doesn't go back. It doesn't get a smaller value than it has already reached. Okay? It might stay here for a while and then increase again. It might stay here for a while but doesn't get smaller. Okay? And then increase. So this is monotonic increasing because once it has reached the y value, it's not going to take a smaller value than that. And what is strictly monotonic increasing mean? It means that it doesn't stay the same for a while, but it's really continuously increasing. So for a greater x, so if this is greater than this, the y value is higher than for this value. So this is strictly monotonic increasing. So this is, for example, an example for the temperature, climate, when we can see an overall increase. But of course, there are sometimes the temperature drops back, or stock market, or whatever. So in real life, we can see this often. Okay? So this function is strictly monotonic increasing. Okay. Now, Let's see. Next one is the function bounded? Is the function bounded? What does that mean? What does it mean that the function is bounded?
It has a lower bound and upper bound.
Yes, exactly. It means that is there a y value under which the graph doesn't go, so no smaller y values are taken? And is there a y value above which the function doesn't go, that is, no greater y values are taken? Is there such a lower bound? Lower bound. So which is the y value under which the function doesn't take? So from 4. Which 4 is the x value. What does it take? What is the y value?
0.
0. Yes. Yes.
0.
So if x equals 4, the y value is 4. So the lower bound is 0. What is the upper bound?
48.
48 for
Upper
y
bound
value.
is 48.
48.
And then
Because nowhere doesn't the function doesn't go above. This is the highest value. That okay, I should have wrote it like here. The function doesn't get above 48, so it's bounded. So since it has both a lower bound and an upper bound, that's why the function is bounded. It has both upper bound and lower bound, so it's bounded. Okay, the next part is very important. It's very important. I hope we understand what I'm saying. Very important. So the question is the function even or odd? Is the function even or odd? This is the question. What does it mean that the function is even? In what case is the function even?
F of 2 is even. F of 2 is even function.
No, if f of x is minus f of x, then it is called an odd function.
Mm-hmm. So
f of minus x is equal to f of x is equal to even function.
Yes, very good. So f is even. A function is even if f of minus x equals f of x. In this case is even. What does it mean? What the hell does it mean? We have this formula and okay, and what? Let's see. If I draw a coordinate system, let's say the domain is the entire R. Okay, which means I pick a number x. Let me pick this number 3. X equals 3. F of x, let f of x be this. So the function takes this y value in x equals 3. Then what value does it take in minus x? Is f of 3 minus x is minus 3, right?
Minus 3.
It has to take the same value, which means this.
Yeah.
Have to be the same value. If x is 5, and let's say it takes this value, then minus x is minus 5. If they are equal, it has to take the same value as here. Okay, and so on. What does it mean? If x is 0, it takes something in 0. Let's say it takes this value. The minus 0 is 0 as well. Okay, so what I can draw, what can we notice? What can we see if we take a look at this graph geometrically? What can we say? That this graph
is symmetrically?
Yes, symmetrical to what? To the
Y.
Exactly, very good. Y-axis, very good, guys. So, if a function is even, then its graph is symmetrical to the y-axis. What does it mean? The y-axis serves as a mirror, right? If this looks at itself in the mirror, this is what it sees. If this looks itself in the mirror, this is what it sees. Okay. So this is geometrically what an even function means. When is a function odd?
F of x equal to minus x.
Yes, f of minus x
is equal to minus f of x.
Yes, minus f of x. Now let's examine this. It means that if we have an x, f of x is this value, then what is minus x? So minus 3 takes what value? Minus 1 times the value of f of 3. What does it mean? This was f of 3, then it takes minus 1 times this, which means the same distance but the other direction, here.
Then it will plot on second and third coordinate, I think.
So f of 5 was this, then f of minus 5, the same distance but to the other direction, because it's minus f of it. That is kind of, if I connect the points, I get this. What can I notice? That the graph of an odd function is symmetrical to the origin. Okay, because the origin is like a mirror. I can see here the same as I see here. Someone should mute the microphone, please. Someone should mute the microphone. So if the function is odd, then the function is symmetrical to the origin. Symmetrical to the origin. So f of minus x takes the same value as minus 1 times f of x. That is, we reflect f of x values to the x-axis. Okay, now let's take a look at our function. This is the graph of our function, right? We have drawn it. If we take a look at this graph, is it symmetrical to the y-axis? Is it symmetrical to the y-axis? Do we see the same here as here, this graph? Do we see it here?
No.
No, we can't see it. Yes, you're right, we can't see it. So we can say that this function is not even. Can we see? Let's reflect it to the origin, which means the mirror image of this would be somewhere here. Can we see something similar like this here? This is the origin, right? Can we see something here?
No.
No, we cannot. There is nothing here. Okay, so it's not odd. Just examining whether it is symmetrical to the y-axis and the origin. It's not symmetric to the y-axis and not symmetric to the origin, so it's neither even nor odd. Okay, let's take a look in another angle. So if f is even is if f of x is the same as f of minus x. So f of minus x is the same as f of x. Okay, let's pick an x. Where can we pick an x from? If we have a function, where can we pick an x from? Only from the
minus x.
We need an
X-axis.
X-axis.
X-axis, but can we choose any number from the x-axis if I want to calculate the function value? Which
No.
axis? So
4.
why not?
4
Where
to
shall I-
10.
Sorry?
4 to 10.
Yes. Why? Why?
Rounded.
So he's saying that in this case, when we want to pick an x and calculate the value of the x, we only can choose an x number between 4 and 10. Why? What is
Domain.
this? This is the domain, exactly. So we only can pick an x from the domain. Let's pick an x from the domain. So let it be, for example, 5, because 5 is between 4 and 10. Let's say 5 is here. So this is the value for 5. Then if x is 5, what is minus x? So if x is 5, what is minus x?
Minus 5.
Minus 5.
5. What is the function value in minus 5?
It is not defined for minus 5.
Exactly. Very
We
good.
cannot take minus 5 because it's not in our domain.
Thank you very much. Very good, guys. Perfect answer. Perfect answer. In place of minus 5, the function is not defined because minus 5 is not in the domain.
It's not even.
It's not even. Exactly, because it's not just they are not equal, that f of minus 5 doesn't even exist because minus 5 is not in the domain. So we are not able to calculate f of minus 5. It doesn't exist in our case because minus 5 is not in the domain. What about when we calculate whether it is odd? Again, we should calculate the f values in minus x, so minus 5 as well. So we can conclude the same, that minus 5 is not in the domain. And doesn't matter which number we pick from the domain, minus 1 times the number minus x is not in the domain. So we have a second proof that this function is not even and not odd because f is not defined in any minus x. Okay, now let's see that if you get this question at the exam, how you need to answer. So please be prepared to this question. So the question is, you are given a function and you have to tell whether that function is even or odd. What do you need to do? First of all, you need to write down this definition. So this is the definition of a function being even or odd. Okay, so this is the first step. You just write down this definition. First step. This is the definition of an f function being even or odd. Then you take your function, what you get, and you calculate these. That is, you calculate f of minus x. What is our function? Let me write it again. F of x equals x minus 2 times x minus 4. Let me multiply these two brackets. It will be easier to get x squared minus 6x plus 8. Okay, it's the same function, but it's easier to deal with. So this is f of x. This function is f of x. What is f of minus x? F of minus x is the function where I substitute minus x in place of x in this function. So I put minus x.
Minus x squared.
Squared, yes.
Minus x squared plus 6x.
No, minus 6 into minus x plus 8.
Yes. So here we have minus 6 times minus x, right? I put minus x in place of x, plus 8. It equals minus x in bracket squared.
X squared.
X squared because it means minus x times minus x, and minus times minus is a plus. Minus 6 times minus 6 plus 6. Yes, plus 6x plus 8. This is f of minus x. Now we compare whether f of minus x, which is this, equals f of x, which is this.
No.
No, they are not equal because here we have minus 6x, here we have plus 6x. So what you need to do, we write down that. We found that f of minus x doesn't equal f of x, right? This is what we have found. We write it down. Therefore, f is not even. Okay, this is how we need to write it down. Now, we need to compare that f of minus x, whether it equals minus f of x. For this, we need to calculate minus f of x. What is minus f of x? It's minus, and I put into bracket, what is f of x? This.
X square minus 6x plus 8.
Very good. I expand the bracket, which means I need to multiply every term by minus 1 to get minus x squared, minus is plus 6x, minus plus is a minus 8, right? So this is minus f of x. And now I compare it with f of minus x, so this, to see whether they are the same.
No.
No, they are not the same, because here we have minus x squared, here we have plus x squared.
Plus
Here
8
we
and
have
minus
minus 8, here we have plus 8. So we conclude that f of minus x doesn't equal minus f of x.
Not odd.
Therefore, f is,
Not odd.
please someone should mute the microphone, f is not odd. F is not odd.
That means f of x, ma'am, neither odd nor even.
Exactly. So the final conclusion is, and this is what you need to answer, f is neither even
Not odd.
nor odd. F is neither even nor odd. And this is the final conclusion. So again, in the exam, what you need to do, write down the definition of a function being even or odd, then calculate the function if f equals f of minus x to find what it is, f of minus x. You compare it with f of x, and if they are the same, you conclude that f is even. If it's not the same, you conclude that f is not even. Then you calculate minus f of x and compare it with f of minus x. If they are equal, you conclude that f is odd. If they are not equal, you conclude f is not odd. So, if you have found that f is not even and f is not odd, then you write the final conclusion that f is neither even nor odd. So this is the entire procedure you have to do in the exam for this question. Okay, this is
One more question, that if the function is even, that means the function is odd also.
No, if you find it cannot be both. It's either even or odd or neither. It cannot happen that it's both even and both odd. Unless it's a constant function, but you are not going to get that. Okay, so you find it's even, or you find it's odd, or you find it's not. It's neither. It's neither. Okay, so this is important. This is an important question, okay? Yeah, and one more here, one more to here. Find f of 1 plus 2t. F of 1 plus 2t. Okay, what we need to do, now this is our x. So in place of x, we have to write 1 plus 2t. So this is our f. So I write, in place of x, I write 1 plus 2t minus 2 times, in place of x, again, 1 plus 2t minus 4. It equals, we have 2t, plus 1 minus 2 is minus 1, times 2t
Minus 3.
plus 1 minus 4 is minus 3. And that's it. I just substituted 1 plus 2t in place of x. And we need the domain. What was the domain of the original function with x? X has to be between 4 and 10. Now the question is, where can t be? T can be between what and what? How can we find it out? In place of x, I replace 1 plus 2t. So we have 4, 1 plus 2t, because this is x now, this has to be between 4 and 10. And we rearrange this inequality to find t. So first I remove 1. So I take away 1. 4 take away 1 is 3. I remove 1, so it's 2t. 10 take away 1 is 9. We have 2t, so but we need 1t, so divide through by 2. So it's 1.5, t, 4.5. And that is t has to be between 1.5 and 4.5. That's it. Okay, now another important exercise is exercise 15. We have function f is given a square root of x minus 3, and function g is given as ln x squared. Find G circle F. G circle F is a composite function. G circle F. What is G circle F? That is G in the place of f of x. What does it mean? It means that in place of x in G, so G is G of x, in the place of x, I write f of x. Okay? So, I start writing G, ln, and in place of x, I write the entire f. In place of x, I write square root of x minus 3. And then squared. Equals
ln of x minus 3.
Yes, so square and square root cancel each other. So we have ln x minus 3. So this is G circle F. Be careful because F circle G is different. This is F of G of x. In this case, G is the internal function. This is inside. In this case, F is the internal function. F is inside. Now, listen now, because students usually can do up until here in the exam, but usually cannot do the rest. So please listen how we need to proceed. The question is, describe its domain. Describe the domain of the gained function, this. What we need to do is, since if we want to substitute a number here, first we apply f. So first we calculate f of x and then g. That's why first we need to find the domain of f. So the first step is find the domain of f. What is f? F is square root of x minus 3. What is the domain of this function? What is the domain? What is the domain of a function? The x is
greater than equal to 3.
Yes, and why?
Because if x is less than 3, then it will become a negative number, and it will
very
become
good.
A complex number.
Yes, very good. How do you pronounce your name, please?
It's Shyam Kumar.
Shyam Kumar, yes, very good, Shyam Kumar. Perfect answer. So, we need to find the domain for f. What is the domain of a function? These are the x's, the numbers, where the function is defined. Where the function is defined. Let's see where this function is defined. It's easier to ask where the function is not defined. Let's see whether there are some numbers where the function is not defined. How do we examine that? We need to check the operations. What operations are there? Here we subtract 3. This is the first operation. We subtract 3. Is there a number from which we cannot subtract 3? Because it doesn't make sense. No, we can subtract 3 from any number. So far, the entire real number set is fine. No restrictions so far. Let's go further. We have square root. We take the square root of this thing. Is there a number from which we cannot take the square root? We cannot take the square root of what numbers?
0.
We can take
less than 0. Less than 0.
Less than 0. Exactly. We can take the square root of 0 because it's 0, but we are not able to take the square root of negative numbers. So
it becomes wild, yes.
Whatever is under the square root has to be non-negative. So we have to write that x minus 3, because this is under the square root, has to be greater or equal than 0. Yes. Now we solve for x. X has to be greater or equal than 3. And this is the domain of f, the internal function, f of x. This is the first step. Now, second step, we define the domain of the composite function. Let's see. What is the composite function? This. Again, we check whether there is some restriction on the numbers for which this is defined. Can we subtract 3 from any number? Yes, we can subtract 3 from any number, so there is no restriction so far. Let's go further. We have to take the logarithm. The logarithm we can take from what numbers?
0.
We cannot take the...
Log 0 is undefined.
Log 0 is undefined, yes. So this cannot be 0. What else cannot be?
X is not equal to 3.
Yes, that's true. So we cannot take the logarithm of 0. Yes, that's correct. And we cannot take the logarithm of negative numbers.
X is equal to 4.
This has to be...
We can take...
positive.
Yeah.
This has to be positive.
We can take more than...
X greater than 3.
Greater than 3.
So, the argument of the logarithm has to be positive. Strictly positive. So, x minus 3 has to be positive. It cannot equal 0. I can't write the equation sign here. Solving this, I found what you are saying, that x has to be greater than 3. Positive. This is the domain for this function. So this is the second step. And the third step is very important. Result of this calculation. We have to take the intersection of these two, because the domain of the function is where both f is defined and both the composite function defined. So the intersection of these two sets. What is the intersection of these two sets?
X is
greater than 3.
X is greater than 3. Exactly. So this is the final result. This is the final result. Okay? Because if this is 3, for f, 3 is allowed, and everything which is greater. For this function, 3 is not allowed, but everything which is greater. And where do they run parallelly? Only numbers which are greater than 3. So again, you find the composite function. Then, first step, you find the domain of the internal function. In this case, it's f of x. In this case, it's g of x. Find its domain. Second step, you find the domain of the composite function you found. And third step, you take the intersection of the two. And this is the final result. This is the domain of G circle F. Important exercise. Okay?
Yeah.
If you have, Any question, anything, please come to my drop-in session on Thursday at 1 o'clock and through MS Teams. You can find the link on Canvas. Okay, if you have any questions, please come because I want you to get a good grade on the exam. So I'm very happy to answer any questions, anything you don't understand, anything you want to practice, or any exercise for which we didn't have time from the tutorial sheet. Okay, next one. Very important again, so I have to talk about this. Exercise 17. Exercise 17. Use the definition of the derivative to find the derivative of the following function. Use the definition of the derivative to find the derivative of the following functions. Let's see. What is the definition of the derivative? The definition of the derivative is lim(s) h tends to 0, f of x plus h minus f of x over h. This is the definition of the derivative. What it means, I can explain it to you on my drop-in session because here we don't have time. But all I can tell you now that this is the definition of the derivative. Okay, in part B, the given function is x squared. So the exercise says, use the definition of the derivative, so this, to find the derivative of x squared. So what we need to do to apply this formula for x squared. Let's do that. The derivative is lim(s) h tends to 0, f of x plus h. We have to find f in the place of x plus h. That is, in place of x, I need to write x plus h. Minus f of x is x squared. Yeah, it's given. Over h. Equals. I expand the bracket to get x squared plus 2xh plus h squared, right? I just expanded the bracket. Minus x squared over h. Right? So this is based on a plus b squared equals a squared plus 2ab plus b squared. Notice that we have plus x squared and minus x squared, so x squared drops.
2h.
So x squared drops. So we can continue that lim(s) h tends to 0. We have 2xh, or hx, doesn't matter the order, plus h squared over h.
2 plus h squared.
Sorry. Notice that there is h in both terms. There is h in both terms.
Commonly.
Common factor, which means we can factorize by h. So lim h tends to 0, and I put h in front, and I write 2x plus h over h. Okay, I divide it through by h, I put h here. So I can simplify by h.
2x.
Now we have lim h tends to 0, 2x plus h. What is this limit? What is the limit of this function as h tends to 0? Since h gets smaller and smaller and smaller as tends to 0, it eventually disappears, and the limit is 2x. Okay? So, let me draw your attention that at the beginning, when I gave you this function x squared, I think all of you would have told me that the derivative of x squared is 2x. I think all of you know this. But in the question, there, what was the question? Use the definition of the derivative. if the question is, use the definition of the derivative to find the derivative of the following function, then just stating that the derivative is 2x is not good. You are not going to get any mark for this. If the question says, use the definition of the derivative or based on the definition of the derivative. If this is the question, then you have to write down this definition. This is the definition of the derivative. For this, you already get a mark. If you write down this, you already get a mark. Then you apply this formula for the given function. You get a function, for example, this, or x squared plus 3x, whatever function. You make this derivation, you do this derivation, and then you get the answer. And then for all these, you get the full mark. Okay, if the question is use the definition of the derivative. Okay, important question. And if you look at exercise 18 and 19, it only says find the derivatives of the following functions. Find the derivatives. It doesn't say use the definition of the derivative, which means in that case, you don't need to go through this derivation. You can just tell that 4x, the derivative is 4, plus s cubed, the derivative is 3x squared. It's fine. But when the question says use the definition of the derivative, there you have to go through this derivation. So please expect this exercise at the exam. Okay, we don't have more time. So please, if you have problems with either these exercises or the exercises on the tutorial sheet, we didn't have time. Exercise 18 and 19 is very important. Exercise 18 and 19, where we have to find the derivatives, is very important. You need to know those. So the solutions will be uploaded. So if you don't understand or have any problems, please come to my drop-in session and ask me. I will explain it because you need to know those for the exam. You need to know. It's important. Okay? 18, 19, derivatives. So my drop-in session is on Thursdays from 1 o'clock. Thursdays from 1 o'clock through MS Teams. You can find the link on the canvas. So please come. If you have time with the date and time of my drop-in sessions because it clashes with something, please let me know. Okay? Then we will find another date and time. Just come and ask me because I want you to get a good grade. I'm very happy to explain anything for you. Okay? So, see you either tomorrow on my drop-in session or the next tutorials, next week tutorials. Okay? So, see you guys.
Thank you.